Let's talk about a word in math that, let's be honest, can sound a little intimidating: logarithms. But what if I told you they weren't invented to be hard? Nope. They were invented to make life way, way easier. They were a secret weapon, a tool designed to solve a problem that was literally holding back science itself. Let's dig in.
So, I want you to imagine something. It's the early 1600s. There are no calculators, no computers, nothing. You're an astronomer, and your job is to multiply numbers that look like this all day long to map out the stars. Just one of those calculations could take you hours of super careful, tedious work. And it was so easy to make a mistake. So how on earth did we get anything done?
And this gets us to our first big idea: a world before calculators. We're talking about an era of just incredibly tedious, error-prone calculations. For the scientists, the sailors, the engineers, this wasn't just some small annoyance. It was a massive bottleneck that was slowing down the pace of discovery itself.
And right here, this is the heart of the problem. But it's also the key to the solution. Everybody knew that multiplying big, messy numbers was just awful. It was so hard and slow. But adding numbers, well, anybody could do that. It was easy. It was fast. And that simple difference is the secret to everything.
So this led to the sort of billion-dollar question of the 17th century. What if there was some kind of magic trick, a way to take a really horrible multiplication problem, turn it into a simple addition problem, get the answer, and then turn it back? I mean, that would be a game changer, right? Well, that genius idea would literally change the world.
And that brings us to the problem solver. That magic trick? It has a name: the logarithm. You see, this wasn't some abstract thing dreamed up in a math class for no reason. It was a very practical tool, invented out of pure necessity to help real people solve real-world problems.
And that was their whole job. That was their mission. Before they were anything else, logarithms were a tool for making things simple. They take something hard, multiplying, and they turn it into something easy, adding. It was a completely revolutionary idea. But, how does it actually work?
Okay, so we know why they were created. Now let's jump in and figure out what a logarithm really is. And here's the secret. Despite the fancy name, it's really just about finding an exponent. That's it.
No, I'm serious. That is the entire secret. A logarithm is an exponent. From now on, whenever you see the word log, I just want your brain to ask one question. What's the exponent I need to put on this base number to get that other number? It's a search for the exponent.
Let's make this super clear. We all know that 2 to the power of 3 is 8, right? 2 times 2 times 2. A logarithm just flips that sentence around. It asks that question we just talked about. What exponent do you need on the base 2 to get the number 8? Well, we already know the answer. It's 3. So we say the log base 2 of 8 is 3. The log is just the exponent.
Now, to actually do that magic trick of turning multiplication into addition, we do need a couple of rules of the game. But please, don't think of these as some scary, complex math. Think of them as a few really clever tricks that unlock all the power of the logarithm.
Okay, one of our sources has this awesome name for the first property. It's called the peteleco rule, which is Portuguese for a little flick. And the idea is just so simple. If you see an exponent inside a log, you can just flick it out to the front and multiply it. It's such a great way to remember the rule. And here they are. These are the two properties that make the whole magic trick possible. The logarithm of two things being multiplied becomes the sum of their individual logs. And the log of a division, you guessed it, that becomes subtraction. This right here, this is the engine. This is exactly how you turn that hard multiplication problem into easy addition. Okay, let's do a super quick recap of the must-knows. First, a logarithm is just a tool to find an exponent. Got it. Second, the base, the little number, has to be positive and it can't be 1. Third, the log of 1 is always 0, which makes sense, right? Anything to the power of 0 is 1. And last, you can only take the log of positive numbers. Those are the basic rules of the road.
So that's the history. That's where they came from. But that leads us to a really fair question. Why do we still care about them? In a world where we have literal supercomputers in our pockets, why bother with a tool that was made to simplify multiplication?
And this really is the key question, isn't it? You might be thinking, okay, if their main job was making multiplication easier, and my phone does that instantly, are logarithms just a historical artifact? And the answer is a huge no. Because they evolved, they took on a new and, you could argue, an even more important job for the modern world.
This is their modern superpower. Think about it. Any time you have an equation where the variable you're trying to find, the x, is stuck up there in an exponent, how do you get it down? How do you free it? There's only one tool for the job: the logarithm. It's the only key that can unlock that cage.
Just look at this simple equation. 2 to the power of what equals 3? Well, it's not 1, because that's 2. It's not 2, because that's 4. You can't just guess your way to the answer. So how do you actually solve for x? You use a logarithm. By its very definition, x times is the log base 2 of 3. You see? The logarithm isn't just a step, it is the answer.
And this ability to solve for a variable trapped in an exponent, it is absolutely everywhere. Trying to figure out how long it'll take for your savings to double with compound interest? That's a logarithm. Measuring the power of an earthquake on the Richter scale? That's built on logarithms. Even analyzing how fast the computer code on your phone runs? Yep, that uses them too. They are hiding in plain sight.
So if you remember just one single thing from all of this, let it be this simple phrase: the logarithm is an exponent. That's it. That one little idea is the key to everything. It unlocks their old-school purpose, making hard math easy, and their modern-day power, solving for variables that we could never reach otherwise.
In the end, the story of the logarithm is really just a powerful lesson. It proves that sometimes the answer to a really, really hard problem isn't a more complicated tool. It's just a completely different way of looking at the problem. And that makes you wonder, doesn't it? What other impossible problems out there could suddenly become simple if we just found the right way to look at them?